As you might have read, today we're talking about time travel. And before you just tune away, go, Christ, this guy's just going to bullshit us about time travel. It's going to be a cool deep thoughts. Because we're going to get into the illusion of time. I'm going to get into some of the notions of how we perceive time. And a little bit deeper than I've ever heard it read anywhere in the world. We're going to touch a little bit of general relativity. And then we're going to try and figure out if there is actually a way to do it. Because I think there's an avenue where one could perceivably do it, but it's not going to be like the science fiction films that we know so well. Time travel. Okay, so most of us are, we know that when you hear that, you know there's people who believe we can go on Craigslist and buy a machine that does it. You know that most of us think it's impossible. And then you will have heard these fringy scientists who write these articles every once in a while that have theorized how we might be able to pull it off. Right? Douglas Adams had a beautiful line in The Hitchhiker's Guide to the Galaxy, and it said, "Time is an illusion. Lunchtime, doubly so." And I think that's pretty accurate. Because what would time actually be? Human beings live chronologically, right? And I'm going to say a bunch of low-hanging fruit stuff you already know, but we've got to say it, because if I don't say it, I can't jump off into a deeper subject. So I'm not here just to regurgitate a bunch of crap you already know. We just all have to kind of time travel is such a huge subject, and all the science that would be leading up to any theory whatsoever are so vast. I've got to say, guys, we're here, and we're going to go there. So just so you know, that's why I'm going to talk this out. But once a creature could perceive change, obviously we thought there was time. And it's extremely important that we do understand that things change and there is linear thought, Now, I did an episode on time that I pulled all my essay stuff. One, no one listens to it anymore, and two, why not redo them in deep thoughts? A little bit deeper. Second time's always the charm. But it wasn't really about time travel. It's about time and the perception of immediate time versus future time. Because I think a lot of us sabotage our lives worried about the future or worried about the past. And I think that that's sad. So I'm not going in that direction. But one thing that's important, we want to understand time travel, is we have to understand where we're traveling to and from. Or maybe from and to. Where are we now? And where are we trying to go? And what is that? What is that thing, If someone wanted to travel to the center of the ocean, it's going to be a different mechanism than traveling to the center of a continent, to the center of the sky, right? So we have to totally understand what the hell we're talking about, or at least kind of come to the general consensus to then apply theories to moving around within that construct, right? But man used to think in the now, and man didn't have the ability to think in the past or in the future. Now, genetics and instinct are different because we do learn how to do things over time. So the elephant that remembers where the water well is, one could say that they're actually conceiving of the past in order to figure out where to go in the future to get water, or it could just be a map in the mind, which is generated from the past, held in genetics, and then recognized as almost a now moment. But the interesting thing is that the philosopher Marshall McLuhan really got into this notion of how man parsed language. We know that looking back, we have iconic languages, which is an icon means a certain thing, right? And then we would just literally talk in the now. Right now, I need this, now I need this, now I love you, now I'm going to die, right? And then we got into phonetic languages. Now think about the difference between trying to recognize a phonetic language word, which is an alphabetical one, like we read today, and then reading just an icon. Think about the conditioning of the mind. An icon is what it is, right? Cigar. Boom. You don't need to spell cigar in your brain. It just is right there in your mind. But if I spelled the word cigar in front of you, it's C-I-G-A-R, right? So your brain is having to put together a phonetic sound table that then has a pattern recognition in your mind, right, that allows you to know what I'm saying. And that forces your brain to actually store everything in a linear way, chronologically in your mind, and then traverse the the typesetting in your brain of which letters are on the stack, your Scrabble board, right? All right. But that evolution had to occur before man could perceive of time. And the second that man perceived of time, I think we got a lot of evolution in man. Tremendous explosion. It'd be the internet times 50 million, right? When man could perceive time. We got this, the equinox measurements, the yearly solstice measurements. I think we got a lot of burial rituals out of that because we realized that we're born, we live, and we die. Now, it's not like the man couldn't appreciate death without linear understanding, but once it became a profound example in the mind of going, wow, you were really small, then you got a little bit bigger, and then you were really smooth, and then you got kind of wrinkly, and then you got super wrinkly, and then you stop waking up. Like a primitive man thinking that through. The sun rising and setting and then rising again. That's a cycle of birth, death, and resurrection. The sun is born. The sun dies. The sun is risen. That's why you have so many of those metaphors inside religion. It's the oldest archetype inside the human consciousness, being on whatever the hell we're on, right? Flat around. Now, I've put a tremendous amount of thought into time travel at times in my life. So this isn't going to be some trivial, hey guys, I think if we drove 88 miles an hour, something special might happen. But the conversation is very, very deep, and I have to get you there, and you're going to have no problem getting there. It's not like, I'm just sharing with you a paradigm to have the conversation. Okay. So let's think about what we are for a split second, because we're talking about, hey, I want to go back in time. And in the Hollywood or the short order version of the conversation, we're talking about our physical body, every blade of hair on my head, every piece of clothing I've got, pushing either forward in time or back in time. All right, that might be a little tough. I don't know, especially if time is an illusion. I like to say that the universe doesn't have a clock. It doesn't have a clock. We have clocks. We measure the universe. This beautiful butterfly hopefully lands on me. It's a monarch butterfly. But we have the clocks inside our brains. It's our perception mechanism that we have that. Now, you might say, well, general relativity talks about space-time. That's still human beings perceiving the universe in a paradigm of XYZ coordinates, your space in the universe, your exact point in the universe, and then T, time. What time are you in the universe? Well, it would be general to wherever we started this theory, because we don't know when the universe started, so we don't have a 0-point Big Bang moment, right? That didn't happen, ever. So the best thing we can do is create a line in our perceived time, draw a cross through it, put a 0 on it, and say that's the beginning. And that's when Einstein came up with his idea. And from that point, we have before time and then after time. But think about the fact that in order for us to think that we have time, and it's really amazing because you think we have time, and I think we have time, in terms of how we manage our lives, inside your consciousness somewhere is a timetable. Inside your consciousness is some linear mechanism, some line of data that is the day before, the day before that, the day before that, the day before that. This happened to me when I was 8. This happened to me when I was 6, 7, 8, 13, whatever. Some people claim to be able to go back before their birth. Who knows? Why would it stop? But there's two ways to look at this. You have your scientific Kurzweil brain theory, which is that everything is just a bunch of chemicals in the brain. It's all secular. There is no creation. We don't have a larger version of life out there. And forget God and all that stuff and religion. Forget all that. But this symbiotic relationship that our soul energy might have with this mortal coil. And that's going to make a big difference in how we can travel through time and whether or not we can. I'm going to just jump ahead and just say, I believe that if you believe, I believe if the secular scientists are correct, meaning we are just simply a bunch of chemicals in this body, then time travel is absolutely impossible. But if you will extend your perception of the human condition to adopt the idea of perhaps some soul energy. Forget religion, okay, I'm not talking about that, but a pattern of energy that is the composition of you. And you are merely attached to this mortal coil at this particular time and place. Then I believe we can find a way to perhaps maybe free that from your mortal coil, be free of the constraint of time and space, and you can traverse the universe almost like a fish swimming through the ocean. There you go. There's a little preview of where we're going with this. But at some point, we have to acknowledge that we have a memory mechanism that we have access to. And for any of you who've done programming in a computer, or you've even watched an MP3 play in your favorite music player, you know that there's a digital file in there, and it's got a bunch of ones and zeros, and there's a playhead, essentially, moving down those ones and zeros, just like it used to be on a turntable with a piece of wax, right? And the needle just kept bumping all those waves. They were strung out in a circular thing. All we've done is we've straightened those bits out. Instead of being, analog sine cosine waves, it's just digital on and off, simulating that other wave. So we're reconstructing the analog wave in memory within a sound card using the bits. Same way JPEGs work. It's a bunch of CMYK data, and we just flow through it and calculate the average light wave that you're going to see at that particular moment in the XY Cartesian coordinate of an image. Okay? It's all very similar stuff. We are a universe of data. And what's fascinating is once you actually see the inside of a memory chip in your mind, you can look at the silicon photograph as well. But once we realized we could store transistor data inside of a chip, an on-off or a null, you pretty much have the fundamentals of the universe as it exists. Now, if you watch the very first episode of Deep Thoughts, you'll hear me talk about this fabric, this binary fabric that we have. And it's not terribly important that you actually know it right this very second, but we have to understand that whatever creates something, it's an information stream. It's an information construct. I say construct a lot because it's an object, right? Now, regardless if you believe this is a computer simulation or some other organic simulation, it really is the same thing. This is, just as much as anything, a computer simulation. It is a grid, a three-dimensional grid, X, Y, and Z, of existence right now, right? I can move through this space. Now, you get a bunch of existential physicists that have fun on paper, and I'll just acknowledge that because, they could be correct. But a lot of folks want to say, okay, infinity cannot exist in a human's mind, but a human can see objects that seem to have properties of infinity. And one of them is a sphere. The surface of a sphere, right? We can move around infinitely. Now, obviously, there's a limited amount of information that could be stored on the sphere as long as there's a fundamental size of the particle that makes up the sphere. Meaning, if you keep zooming down into the bowels of the sphere, if you can get to the fundamental particle, the fundamental binary packet of energy that cannot be anything less than what it is, then you have a finite amount of space on that sphere. Now, if for whatever reason it within itself is infinitely macro and micro, somehow you go down into the bowels of a sphere's binary data, and somehow you create another universe inside that object, and then you can zoom all the way down into the next thing. Who knows? So they've created these objects for us to see, and there's a bunch of mathematical models where they take a sphere and they'll turn it inside out mathematically in Mathematica, and it just feels cool when they pull off a mathematical miracle like that. They see this object that's really strange, and they say that's the way the universe is built. They just love to do that. It's just all arbitrary, right? We obviously don't look out into the universe and see any type of sphere turned inside out structure. If anything, we see the inside of a sphere at most, right? There's the other one that's called the Mobius strip. You take a flat band that sort of has its own infinity, and someone cuts it and rotates it 180 degrees and reattaches it. That made people feel really amazing. You should go check out the book Gödel, Escher, Bach. It's got some amazing epiphanies bringing these three gentlemen together. And it's all about the mathematics of the mind and culture, and it's just a phenomenal read. So I mention all that crazy weird shit because at some point, in order to have the conversation about time travel, we have to figure out as close as possible as to where the hell we are. Where are we right now? And we don't actually have to know we're in Toledo, Ohio. We just have to know, okay, we're inside this mechanism, you know? Are we in the Tron universe and I'm just a bit inside a memory computer? Memory computer, that's great. Am I just a bit in memory, right? And then if I have arms and legs, I take up a little bit more memory. And if I can throw a disc, well, that's a little bit more memory and another piece of AI that attaches to the disc, right? So whatever we are, we're probably some level of a finite amount of information that makes us up. And it's the change of this information that gives us the illusion of time, right? So that's the first thing we have to acknowledge is that, you know, time is not this objective thing. It's a subjective paradigm in that I can see things change in the universe. Do you think the universe cares if a particle changes? I don't think it does. Now, someone might say, well, there's a divine spirit looking over the universe and that person cares. All right. I don't think we can have a time travel conversation and talk about God at the same time. I just think that's going to be way off to the side. This is going to be purely secular, purely scientific. And if I mention soul energy, it doesn't mean religion. It's just I'm using a word that you understand. I actually prefer the Native American term spirit. Now let me throw at you a paradigm of thinking about the universe. Imagine a grid. I forget what shape. You can imply whatever shape you want. It's spherical, sphere inside out, whatever. And it's a grid of three-dimensional coordinates, an X, Y, and a Z. And within that is the infinite density of everything that could possibly occur. And, you know, man likes to think of the imaginary number, lowercase, italic I, which is the symbol for an infinite number set, right? We like to think about that because it's just fascinating, you know? And it definitely is fascinating. I would never say stop thinking about it. But there might actually be some quantum singularity. And I don't mean a black hole or anything related to a Big Bang theory. I just mean a packet of energy that simply can't be any smaller than what it is. And to just leech off my first episode, the way that I, after several years of sort of coming up with physical models, because I really like physical models, I think it is possible to conceptualize the universe in a physical model. And the most fundamental fabric of the universe that I could come up with was a single particle that spins in a particular orientation, let's say right to left. And you know, if you took another sphere, I just use spheres because they're handy and they're just symmetrically beautiful, right? And you push another one up against it, you know, it's going to rotate the opposite direction. Well, the next one over is going to spin like the one to its right. So the one on the left is going to spin like the one to the right. And so we have this beautiful pattern, this checkered pattern of these binary spinning spheres. Every other one is spinning the one direction. Every other one is spinning the opposite direction of its neighbor. And that creates a beautiful positive, negative orientation for particles. And all it has to do with is what direction it's spinning, right? And there's a lot of theories in the existing science that uses spin one particles and that kind of stuff. And if you were to infinitely densely pack, wow, that's a weird one, pack these things together in all directions, right? And it may not be that tops touch tops. Maybe it is. Maybe tops go in between the other tops, like the 4 points, and there's one in the center, you know, where one lays inside the other. But I think that once you were to have something like this, this fabric, you would get these bumps, these discharges of collision, and the velocity of those collisions might create the energy that we think we see, and we might be made out of all those collisions. You know, we're all made of the same stuff, right? It clumps up into bigger things, bigger atoms, right? So you might have a carbon atom versus a hydrogen atom, right? But in the end, we're all made from the same stuff. And we keep looking with these particle accelerators. We keep trying to split things and look further down and further down to find different quarks and then subquark, objects. It's not important that we actually, to have this conversation, know exactly what the smallest thing might be. What we just need to understand is that there is this fabric of existence. Now, there's a lot of theory right now, which is pretty sound, that talks about a holographic universe. And holographic universe would be the tracking of the collisions of this fabric. So as the fabric collides with itself, okay, because it may be some type of wiggle, we're going to get into a bit of infinity and finite because we have to define basically where this thing exists in some container or not container. But the holographic waves that they keep talking about, the energy waves that collide that create what we see, because everything that we see is a frequency. You're hearing me due to a frequency colliding against your ear. The whole planet and the universe is all energy banging into each other. Energy that moves slow is stuff that you can see like this. Energy moves fast, becomes ethereal winds and gravity and a bunch of other stuff, right? But the reason why it all gets along is because it's all made from the same stuff. It divides into subspecies based on its trajectory and its velocity. But it's all the same exact stuff. Which is why and that should be sort of an exciting realization, because it opens up the conversation for potentially traveling through time. Now, we have to isolate the universe a little bit, because we have to figure out how big the playground is in this thing. Now, the universe has a few constraints that we have to sort out, right? How much space does the universe occupy, and how much energy is within that space, right? There's really three choices. There's infinite, finite, infinite, finite. What does that mean? Again, the container has a size, and maybe it's a subjective observation of the container. Well, let's just say there's infinite space, because there's nothing that would stop it from being there, right? We don't have cardboard box sizes or walls, right? Sides. And then you would have a infinite amount of energy within that. So you would actually have either an is, where there's infinite energy and infinite space. In my brain, I always think of the number set, right? You can always count to infinity, right? So the idea is that maybe energy in an infinite would be constantly growing in all directions, which is that's the way man perceives it, but maybe it's just an is. Maybe it just is infinite. Now, weird thing is it's not, as we look out into space, it's not densely packed. We don't just live in a big white object where everything is in the same state. We know that the universe contains different states. I have space between me and this microphone, which means there's definitely different states of energy between me and this camera, right? Now, the other one is finite. There's a finite amount of space and a finite amount of energy within that space. Interesting. We still have variable densities and variable compositions, because there is, again, my fingers are different than this cigar. So we know that there's different states. For me, that screams of a limited amount of energy, because of the fact that we have these perceivable vacuums between objects. If it was infinitely dense, which would be any definition of infinity in terms of supply of energy within a space, then everything would just be a solid block of energy. And it would never be anything else, because it couldn't be anything else. So I believe that through the fact that we have variant levels of energy realized, that we do live in a finite amount of energy. Then there's the middle one, which makes me feel a little bit better, which is infinite space, because again, you need energy to create a container. And so let's just forget the fact there's no container. It's just out there. And then you have a finite amount of energy within this infinite space. And I believe that our little fabric friend, the fabric analogy, is sort of like the string theory back in the day, which has been deprecated, all right? At some point, all this energy is connected together, because if it wasn't connected and if it wasn't linked, it would simply diffuse into this infinite space, and we would cease to exist. We would have never probably existed to begin with, right? Definitely no Big Bang, right? One of the biggest problems with the Big Bang, just to do a little digression, is that the Big Bang relies on gravity pulling matter together, all right? I think gravity, it would have to be an external force pushing on the Big Bang, meaning that there would be a fabric of energy outside of the Big Bang that'd be crushing this thing together. And so I feel like, your string theory was the closest thing you could do, and just say, no, it's self-collapsing. It's all connected together and it self-collapses. So we have to mention this because we have to get on the same page with what the hell are we traveling through. Now, let's invent a new theory here. We're going to call it the snapshot theory. The snapshot theory is taking the entire universe and taking a snapshot of it. The state of all particles at this exact time. Now forget general relativity, which basically was an exercise in perception, exercise in perceived time. One of the greatest examples I've ever heard about general relativity and time was that if you had a creature, take a man, and you stretch him to be 1 light year in height, and you stand at his head, and he moves his foot, right? It would take a year for the light to get to your eyes so you could perceive that his foot has moved. And that was this big epiphany about how, the general relativity was introduced to the mind. It was like, oh my God, you're right. Okay. Doesn't matter how long your mechanical mind took to perceive the foot to move. It still moved at that exact point in time that it moved. So there is a snapshot theory that I'm going to impose on this argument to say, look, the universe is at any one particular state, at whatever finite moment in time you want to actually say now. Okay? And you don't have to worry about how divisible your measurement of time is, because it is simply the now. The now is an infinite cross-section in the table of time. You don't need to be big, small. Time is infinitely precise when you say now. Now is the most precise thing you could ever mention in physics, right? So if you're to travel through time in the traditional sci-fi manner, you're talking about capturing some part of now, a finite amount of particles. Let's just use your body. Your body's going to go back to 1955. So I'm going to take energy that is perfectly balanced with the entire universe, right? There's no vacuums in the energy of the universe. And I'm going to subtract it from here, and I'm going to add it to the past. Poof. Now I've overbalanced the past with more energy than it's allowed to have. All right. So you might immediately say, well, that's easy. We're going to take the energy from the past, an equivalent amount of energy from the past, or we're going to move it to the future and replace it with a vacuum. The invisible energy that people can't see. So you get some air and move it here, and we'll go human body back in time. And then we have an even swap. Now, splitting hairs, we'd have a chronological issue with how do you actually make this move to here and that move to there instantaneously, such that we don't have any imbalance between the two. Maybe the universe explodes if you do that. But that's a paradigm of travel that we get out of movies based on time being actually real. All we have done is change the state of the energy that we're here right now. Time does not exist at all. It's only up here for us to manage our lives, right? So it's a complete perception of change. It's a historical record of change. So let me throw this at you. We are so sure, especially from the Kurzweil world, where they think the mind is just up here, just a bunch of chemicals in the brain. And because they can open up a skull and touch and prod on the brain, and they make us, have memories or what have you, think, see, look, it's all inside the brain. We just don't know how it works. Don't ask Kurzweil. He thinks he knows how it works, but he just simply can't explain it to you just yet. But what if life, as we actually are experiencing it, is a symbiotic relationship between energy that creates this universe that we can perceive and mess with? And maybe we are made out of something that's untrackable, unbound by the fabric that I talked about earlier. Well, then we have consciousness. We have a fabric of consciousness that is different than the fabric of existence. Oh, now that's interesting. Let me give you a term for it so we can just talk about it. Let's say that life force is completely and utterly different in every way, shape, or form than energy. Life force is its own thing, unbound, let's just say, for the most part, by energy. Maybe life force is sort of a current of its form of energy that moves through the energy that we have here. And maybe it has a velocity. Maybe it slows down. Maybe it's nebulous. Maybe it's like a nebula, like the old Star Trek episodes back in the 60s when they would have like a consciousness, or even most of Star Treks, when they have an alien life form that penetrates the walls of the Enterprise and moves around and then sinks into somebody's head, right? And all of a sudden, there's somebody else, right? Interesting. Well, if time is just an illusion of perception, and if we take that perception one step further and say perception is simply a mechanism of your life energy, your life force, then maybe traveling through time is nothing more than moving your life force into different states of the universe. But the question is this: is the universe really changing? Is it really changing? Or are we just falling through an infinitely dense mesh of all possibility? And what does that mean? It means the following. Any of you have seen a pachinko game? A pachinko game is a Chinese game where it's very thin. It's a kind of a wall, has all these pins in it, and you shoot a ball up, almost like a pinball machine. You shoot it up to the top, and it falls down these pins, and it can fall into these flowery things and do all kinds of wild stuff. But forget all the moving mechanisms. Let's just say a wall with pins, and the ball's bouncing and bouncing and bouncing until it falls into the bottom below. All right. It's a beautiful analogy of what I'm saying, because the pins don't move, and the board isn't redesigned ever. It just simply is a wall of pins, and we are the ball moving through the pins, having these state changes, right? If I ask the board where it is, it's always in the same place. And a pinball machine is almost perfect, but the flippers do move, and there's bumpers, and there's different state changes in a pinball game. So it's not quite the most perfect analogy, but the pachinko game is fantastic if you just remove it down to the pins. The pins don't move. The pins are fixed, and we are the pinball moving through the pins. And no matter how many times you play that game, as long as the metal inside the machine doesn't corrode, the pins never move, the balls always do. And there's almost a birth, death, and resurrection within the ball's lifespan, right? Because being shot out of the womb is being shot out of the kicker. At the very top is the beginning of your life. And poetically, you fall through and you have this journey. And then you're contained in the bottom container with all the other souls, and then you come back out. It's this beautiful thing, right? Well, if I said, here's a magnet, pretty powerful magnet, and there's the glass in front of this machine, so you can see the ball move on the pins. And as soon as the ball comes down and starts bouncing into the pins, I want you to take the magnet, hit the glass with it, and stop that ball in its tracks. From the ball's perspective, you have stopped it in time. It's now frozen in time from moving down to the bottom of the board. And now if I told you, take that ball back in time, you would simply take the magnet and move it up the glass, back towards the womb. You might be able to even get it to go back into the ejection, column, the little funnel, and get it back down to the popper, the little bumper thing at the bottom. I'm using all the wrong words right now, but you get me. Now, that's pretty easy because that's to understand, because it's a very two-dimensional board, relatively speaking. It's almost like a Cartesian XY coordinate system, right? But now let's take that and let's move it into every dimension that we know that exists. Again, T, we have to throw it out. T is going to be imposed on top of the state of the universe at the moment you are in it. Now, what I'm going to tell you is very existential and just a complete idea from me, and it's not anything we can necessarily prove. But the frequency model of quantum mechanics and quantum reality has actually been in a Star Trek episode, I believe in Next Generations. I think Riker was following through time at one point. Maybe it was Worf, I can't remember. But the idea is this. The universe could be an infinitely dense pachinko game of every possible reality that could possibly exist. And that may not be infinite. It just might not be. So you would basically split it here and say, well, there is a finite packet size out there, where energy can only go down to a certain size and it can't go down any smaller. And because that is finite at the bottom, there's a finite number of combinations that the universe could be in. Now, it's way more intense and way more dense than we have. But I've always thought it was interesting when someone said every eventuality that could happen is happened, and we're just falling through the eventuality that our system is falling through. Now, remember that life force analogy, okay? Your life force analogy is the ball in the pachinko game. It is what you are. And this three-dimensional universe that we have attached ourselves to have this experience that we call humanity and the human condition in this particular universe is where we perceive there's limitations. It's where we perceive there is time. Now, the interesting thing about a symbiotic relationship, just to split a hair, before, again, this is important because we're trying to figure out what we are and where we are, because that's the only way we can ever perceive traveling through time without a nerd sitting with a bunch of paperwork and just writing T everywhere in a formula and going, see, I got T to subtract. Yeah, it's back in time. But to accept the idea that we have a symbiotic relationship between our souls and our bodies, we have to accept the fact that there's some combination between the two that attaches for this brief moment in time of change, of state being, this combination where we're together. If I have a soul, all right, then something that my body's doing right now has got my soul attached. And it's not easy to detach my soul from my body. I can't ride a roller coaster and get shaken so fast that I shake my soul out, right? It doesn't happen. We don't have dead people at the end of rides, soulless bodies at the end of the rides with no mechanical problems to their hearts or anything. It doesn't happen. Now, again, I would imagine that the gravity that applies to our bodies in this universe has no role in this other realm if there is such a soul, right? Now, someone who's secular goes, see, that's proof. That's proof it's just all the chemicals in your mind. All right. Someone needs to explain the Walt Disney thing I mentioned in the last episode, if that's the case. So there would be some sort of combination. And what's interesting about it is the brainstem is really one of the most fragile parts of the whole body. It is the one thing that if it ever gets damaged, you simply lose life. And you might say, well, the heart is too, and all this other stuff. It's like, okay, you can pluck an eye out. You can knock someone's heart out of their body, and, for a few seconds, they'll still be alive. They'll feel the heart attack occurring. You damage a brainstem, there is no split second of life after that. You are simply removed from your body. It's instantaneous. It's amazing. Now, I'll tell you a story that's, you may not believe it, but my grandmother was a teacher for 36 years. And she taught this kid that went off to become sort of a Top Gun. And he came to visit her once. It's really crazy. My grandmother's students, she taught 4th grade, for God's sakes, right? She didn't teach college. She's a brilliant woman. But she made such an impression on these kids that her entire life they came back to visit her. It's like, man, I can't even remember who my 4th grade teacher was. I got spanked by the principal in my 5th grade class, so I know who she was. She's a nice lady. I just was being a little bit of a jerk. Go figure. So anyway, he came to visit my grandmother, and he said, I just got diagnosed with this really crazy medical condition. And this is relating to my soul-body theory. And she's like, okay, well, what happened? He goes, well, I was getting migraine headaches all the time. And they said they did an MRI on my skull. And he said, I don't understand this, but they showed me the inside of my head. And he goes, my brain is half the size of everyone else's brain, meaning that there was chemicals that encircled his brain cavity, encircled his brain. His brain was really small on the end of his brain stem. But here this kid is decorated, Top Gun. I'm not sure he was a Top Gun, but he was definitely a pilot. Decorated, and he couldn't figure it out. And he was going to have to, I think the whole thing, and that he was going on disability because he wasn't going to be able to fly anymore because the headaches were getting so bad. And I don't know what happened to this guy, but it's just the most bizarre thing. So I thought, wow, even with a really small physical brain, and we know people who have their brain, was a famous guy that got shot. His frontal lobes got blown out by a shotgun, and somehow he maintained his sentient life. He runs around the internet now with this crazy caved-in skull. He's like this gangster. We know people that have diseases and strokes where they remove half the brain, and they're a little bit paralyzed for a little while, but then their right, whatever brain is missing, whatever hemisphere of the brain is missing, the other hemisphere educates itself. So it's interesting how the Kurzweil idea, and I'm going to pick on this guy at all, but he's just cool because he's very secular, and he's very the brain is everything kind of guy, right? But every time the brain gets severely injured, these people tend to recover. It's really fascinating. So for me, that every time I see the brain recover like that, for me, I think it makes sense because it's just the conduit. It's just the conduit to whatever the hell we really are. Now, the reason why I beat this whole thing up on the spiritual level, again, not a religious level, but a spiritual level of life force that is us, is that I want to say that I don't think there's any mechanism whatsoever to travel back in time by taking your cubic space from our universe and somehow convincing that space, okay, to go back to its previous state. Because that's all you're asking the universe to do, is to say, hey, could you undo all of the change that's occurred in what you are? Because either the universe is a statically dense combination of all things that could occur. It doesn't move, and we're the pinball that goes through it, which is a life force argument, or it is a truly moving, very loosely dense collection of maybe stringed together energy. Okay, forget how string theory actually told you how it works, but it's some theory of everything constantly changing, and we are just literally riding it like a horse through the wilderness. And you're trying to convince the horse to not only go back to where it was, by literally running backwards, but to reverse the state of the forest and the animals and where everyone else was in the universe, so you could actually live back in the past. I just don't think you can convince the universe to go backwards in a physical state. Now, a lot of the Buddhists of the world have said that and even the people who did remote viewing, and a lot of the people in the more existential research divisions, where they've spent like billions of dollars through government funding, they'll always tell you that the consciousness, the mind, is the way to travel through the universe, physically and in space-time. That you can take the ball, which is your life force, and you can convince it to go backwards or go anywhere, really. But then it begs the question, if only the soul or the spirit or whatever the hell we are can move through this 3D space-time, or 3D space, I should say, I guess you could put T in the universe of the densely packed eventualities. Then where would you be? Where would you stop to observe if you needed three-dimensional eyes to experience the past as you wanted to experience it? I grew up in Kansas. I grew up in a town that was at least, and beautifully so, like 50 years behind everybody else in terms of architecture and what have you. Technology, we didn't do too bad. But how would if I could get my pachinko ball to go back to 1955, a year I never lived in, and I'm there. How do I engage the reality such that I can see it like a human being sees it? Wouldn't I need a human body to do it? Interesting, right? You might say, well, find a woman who's about to get pregnant and attach yourself to her egg once it's fertilized, and you can become the life force within that being. And you'll be born in 56, and you can experience life in a few years once you gain consciousness. Oh, but by the way, when you do attach yourself, you do seem to forget everything that you had experienced up to that point. Problem, right? Start to get really complicated. Man has a really hard time with the answer no. And so we push and we push and we push. And we get irrational with our denial of what we want sometimes. And other people, they cower down way too fast and they give up everything they could possibly have, Now let's take a break from that super duper deep stuff, and let's talk about whether or not time travel has ever been done to this point. Because it's also a fascinating bumper on the end of the conversation. We get down to the esoteric nature of what would need to happen to move through time. All right. Let's just forget our own struggle and say, has anyone else done it? Now, if you ask people on Coast to Coast AM, they'll definitely say it's possible. And it's happening constantly. And anyone who's a celebrity or a big politician has definitely done it recently or done it in their past. I think we can safely say that if time travel is possible, it's not possible to go back in time within the timeline that you're in, right? If anybody in our future or our past has either gone into the future or into the past, they're not going into our timeline. And I think that would be sort of absurdly obvious that if you could travel through time, there wouldn't be any limitation in going back to your own timeline. Meaning, if I went back to the 70s, I should meet myself if I can do it. I should be able to meet myself. There shouldn't be any limitation with me traversing backwards through the universe and getting right back to this exact frequency of existence and meeting myself. And you know for a fact that someone would. And someone would break the cardinal rule of disrupting the time continuum, and they would screw everything up. On Coast to Coast AM, they tend to say that these are like PSYOP people, psychological operation people that go on that show and they practice bullshitting, and they also field test various theories to see how they're accepted. And I'm not sure George Norrie understands that that's what happens from time to time, but it's no consequence to us. Have fun, man. It's like great role playing, But people say, well, the elite of the world have all this special technology and they can travel to other planets and they can go back in time and all this other stuff. Now, I wouldn't know whether or not they could get to other planets. I would assume they can't, but maybe they could. That doesn't have any problem with the polluting the timeline. But I'll definitely tell you this. If the elite of the world had the ability to travel through time, they would be doing it constantly, and the world would be nothing like it is today. Right? There wouldn't be any mistakes in the world when they engage in deception or when they engage in war. They go back and correct all that stuff, right? Someone wouldn't marry the same person, They'd have pure bloodlines, perfectness, and there are probably a lot less people on this planet because they would control that too. But they're constantly trying to fix the organic chaos that is reality. And so you can assume that any theory that someone gives you about someone being, capable of traveling through time, it'd be one of two things. It'd either be a perfect, chaotic, weird world according to their brains, all right, or they would simply disappear from our existence because they would leave this timeline, go back or forward. And forward is dangerous, right? Forward, you don't know what's going to happen. You could go forward in time, and if you could work out the three-dimensional space in the universe, which we'll get to in just a second, Maybe it's a Holocaust. Maybe the world got destroyed. So you don't want to take any chances that way. You only want to go back to a fixed amount of time where, you want to, maybe a Jew wants to kill Hitler. Maybe someone wants to be Alexander the Great, But you better believe they'd never lose a war. Custer would have never gone down into that valley. None of those mistakes would have been made. Okay. So the other one that I hear from physicists I just mentioned is that there is a super duper requirement. If let's just say I said you can travel back in time, and this is a machine. I'm going to give it to you. It's about the size of a shoebox, and you can dial in the time that you want to go back to. But you're also going to have to dial in where you are in the universe. Now, let's just go with heliocentric globe Earth. Circling the sun circles the galaxy, and the galaxy flies through the universe at some pace, right? Well, the Earth rotates at approximately 25,000 miles an hour. We're going around the sun at 67,000 miles an hour. I forget the speed of the sun through the galaxy, and I'm not sure anyone knows how fast the galaxy is going through the universe. But that's really super duper fast. So even if you want to go back 1 second in time, if you were to capture this XYZ right here, right exactly where my fingertip is, 1 second later, I am really far away from where that point in space is. And so if you travel through time, you're going to have to also move yourself physically to where you physically want to be in the universe. And again, if we're on a ball that's spinning and all this motion's going on, then you have a problem if you want to go back to 1950s, because where the world was in the universe in 1950s, I would imagine is damn near incalculable, right? And what's the world coordinate system that you would be talking to be able to go back, right? Again, the universe isn't providing, a 3D model. It's not the inside of Maya's rendering engine or the GT Interactive Unreal Engine. You can't just ask the computer, well, okay, where we are right now? Okay, we're in an offset of negative 35 billion gazillion this way, and then plus minus this. There's no knowledge of where we are physically. So again, if we're to travel within this time frame, or even to different time frames, you're going to have to physically put yourself in the universe where you're going to actually end up. And that's a problem. And I think it's impossible. Now, I don't think a lot of people actually think about traveling through time. Seriously. I mean, it's a great storyline for a movie, but I don't think there's anyone in mass numbers worried about traveling through time to fix their problems or to simply deal with their reality. We all have regrets. In a particular decision in the past, we would have changed a particular decision. And again, usually it's the tiny ones. It's a really small one. Oh, I wish I hadn't walked into that store, met that person. Wish I hadn't bought that item at the store, and lost all that money. So let's talk about wormholes, just for a little bit, to button this thing up. Wormholes are based on general relativity. And again, it's that eyeball perception of time that makes space-time fabric have any reality in our minds, right? Now, what's interesting about general relativity is that it does help the human mind perceive what's going on and how to deal with it in terms of three-dimensional space, right? I think that what general relativity really is saying, without saying it, because I've been through so many books over the last 30 years on this subject, and been through college courses and talked to geniuses, and no one ever just puts it in simple terms. And we're going to talk about it just a little bit in our 100th episode of MK Ultra. What the general relativity does for me, and the space-time fabric theory does for me, is it simply says that the more gravity you have exerted on your collection of particles, which are energy, the more change that is affected on that energy. And that makes sense. If I just held this cigar out in front of you and didn't exert any more energy than just holding it there unlit, it's never going to light itself and smoke itself. But it's because I'm exerting energy on it. I'm putting flame energy on it. I'm puffing through it and sucking the kernel, the cherry of the flame through the cigar, that it's changing into carbon, right? And a delicious whiskey tobacco flavor. So there's the theory that when you take time, you take a clock, and you take two clocks that are atomic clocks. And atomic clocks, just for those of you who don't know, is that in the bowels of the clock there's an isotope, a radioactive isotope, that has a chirp of its emissions. And they measure the chirp of the emissions to lock down its cycle relation to the Earth's spin and sort of the timetable that we've chosen to recognize, which is 24 hours, 60 minutes in an hour, 60 seconds in a minute, etc. If you sync these two clocks up and you put one at the top of the Eiffel Tower and one at the bottom of the Eiffel Tower, and you don't move them, let's just say for 100 years, and you pull the clocks back down to the same gravitational force, you have the one at the bottom has moved a lot further than the one at the top relative to the differential, right? And I honestly don't know. I've read it a million times, but I forgot how many seconds or quarter seconds it actually advances. What ends up happening is the one down by the Earth moved a lot more relative to the atomic signature of the other one, which means that the isotope itself bled more at the bottom and bled less at the top. And what would cause the reaction of an isotope losing one of its electrons? Force, right? But all that really suggests is that, and it's very, very important to understand this, is that the rate of change, the rate of state change is variable throughout the universe. Everything's on a curve. The one at the top of the Eiffel Tower is on a slightly less curve. It's interacting with less energy. Might be minute, but it's less. And this energy is welled into the Earth through this gravity wave, this gravity bubble. All right? So the more gravity that you can exert on something, the more energy is actually there. But what if it's the inverse? There's this theory of ether. And oddly, it's spelled a couple different ways in history. One is E-T-H-E-R, and one is A-E-T-H-E-R. Ether was tracked by Faraday and tracked by Tesla. Those are the two main ones I want to mention. They tracked it, and Tesla actually tracked it at 50 times the speed of light. But it's heavily misunderstood as they discovered it. If you go on the internet and watch these videos about proving ether doesn't exist, well, you have physicists that just threw it out the door because they couldn't figure it out. But then people that want to acknowledge that it might exist, they always treat ether as this wave of energy that's uniform. It's moving in like a bunch of bullets moving in a straight line, and it's like a flock of geese that just move all in a densely packed wave of energy. Everyone's just flying perfect distance from each other, right? That's not the way the ether was ever theorized back in the day. Ether was always a chaotic wind of energy. These particles that are just fluttering just like the wind. It's almost a perfectly uniform, chaotic wave of energy. And I'm splitting this here because we need to talk about, if you want to move through the universe in time, you're only talking about moving through the universe in its previous states of existence, if you're going to go back in time. Or if you're going to go in the future, you'd have to predict how everything is going to change in the future. If you read the book Chaos, way back in the 80s, he'll talk about you have to know the state of every single measurable amount of energy in the universe at any one point in time. You have to know its velocity, its trajectory, its spin, and everything that's going to bump into it. So if you have to know everybody, you could predict the weather if you knew where every particle was on Earth and everything that was going to interact with it from space. You can figure out where all the storms are going to be. So we do these crude analysis right now, which is actually getting pretty damn good. They can figure out where things are going. But I said that what if the state change of things is actually the inverse? Where gravity, which we believe to be stronger at the surface of Earth versus far away from Earth, which I think we've essentially proven, all right? If you go with the ethereal model, gravity is simply a void of ethereal winds. which creates this attraction between two objects. And I mentioned it in other episodes, but since we're here, let's redo it. If you and I are in a park, just imagine yourself, if you're watching the video especially, you're 100 feet away from me on a really, really windy day. And let's just forget the soil that's beneath our feet. That's just going to be a relative thing we ignore. You have a lot of wind on your chest plate and a lot of wind on your back. Consequently, probably some wind pushing down on your head. But let's just acknowledge the wind that's between us. Okay, forget the vertical wind, just for this example. This is happening in three-dimensional space on an ethereal level, if it exists. But 100 feet away, or maybe even 100 yards away, like a football field, you're way down at the end zone on one and I'm on the other. You know there's no void of equal pressure on your chest versus on my chest. We're getting pretty much the equal amount. But now let's start walking towards each other slowly. Maybe 50 yards away, still pretty damn even, right? But now let's walk a yard away from each other. We're 3 feet from each other. Now we can sense that we're there. I can sense you're in front of me, and you can sense I'm in front of you. Why is that? Because the wind that's hitting my back is being blocked from your front, and the wind that's hitting your back is being blocked from my front. You're basically a windshield in front of me. Okay, so how much pressure is on your back, and how much pressure is on your chest? There's a hell of a lot more on your back than is on your chest, because I'm blocking the stuff that's hitting your chest. And by the way, you're blocking the stuff hitting my chest. So now there's a negative pressure between the two of us. And with this chaotic ethereal wind, we now have attraction. It's weak as hell, and we have to be pretty damn close to each other to actually make it happen. When you talk about a ball that's potentially 8,000 miles thick, it's got a lot of blockage. And it's simply mass blocking mass, energy blocking energy due to collision. So we might be held to this planet, flat or round, okay, by merely the Earth displacing all the ethereal winds that's coming up from the bottom. And because there's an equal amount of pressure from all angles, the only wind that's not hitting us really, really hard is the wind on our butts below us, which is why we're yanked down to the Earth. So that would mean that the closer you are to the Earth, the less energy is actually being exerted on you, at least in one vector underneath you, which is causing you to be pulled down. So now take that clock analogy, the one at the bottom of the Eiffel Tower. Well, maybe it has a lot of freedom because it's having a lot of the energy that would intersect that mass blocked. But maybe the stuff at the top of the Eiffel Tower actually has a tremendous, well, I shouldn't say tremendous, but a little bit more. Now, if you were trying to restrain a human being in a crowd, or if you've ever been in a really intense concert, right? Where do you have the most freedom to move where you want to move? In an open space within the crowd. And if you've pushed up to the front lines of a concert and you are squeezed between the barrier and everyone behind you, or maybe you're in the middle of Mardi Gras. I had a friend of mine who went to Mardi Gras. He said he's probably about 200 pounds. He got so compressed in the crowd that they compressed his body, lifted him off the ground. They weren't trying to lift him. It just happened. And he actually traveled, he said, a block down Mardi Gras Street. I forgot what that street's called. Shame on me. But he got moved down the street without touching the ground because he was so compressed. But he didn't have the freedom to do what he wants to do. Interesting, right? Those of us in our living rooms, we're moving like crazy. So imagine the isotope coming off of an atomic clock. The isotope with less pressure gets to move more freely, gets to exhaust its force because it can. And the one with a little bit more force that's higher up actually gets compressed more. Interesting, right? So if there was some way to calculate going through time, one would have to take in this differential of where you are in the universe to figure out how much of the past state changes you're going to have to acknowledge to get back to the previous state. Wild, huh? So it'd be best to work out the way to move your spirit. But then you're going to have to figure out how to land. Your spirit will have to find the energy in the universe that was where it was when you want to go back to it. Now, obviously, the best way to do it would be to somehow create an instrument that would look back for you or look forward for you, essentially through a looking glass, and capture the state, the visual state of the future or the past, and figure out, we need to be right there, almost like locking a target on some missile, You have to lock onto the future, lock onto the past, and travel directly to it, hopefully not disturbing anything in between. Let me finish up with a really esoteric thing that happened when I was doing a lot of studying in black holes, especially the antimatter rim around event horizons. And this is probably bullshit theory, but whatever. And I think it was Hawking's book that really revealed this to me. Way back in the 90s, there was a theory, and I'm not sure if he came up with this, but he's the type of guy to have come up with it, that a single particle has an infinite past and an infinite future. A single particle has been in all places at all times in potential history. And I don't know why anyone would actually say that, but maybe they've really thought it through in a deep thoughts that we haven't heard. But let's acknowledge that 100% and just think what that means for a second. If there was even one particle in the universe that had an infinite future and an infinite past, again, basically it's everywhere all the time. How many particles do you need in the universe? Just one. Just one. I think it's more of a gimmicky theory, but that's kind of interesting, isn't it? We worry about infinity as human beings because we can't perceive the infinite growth pattern of infinity. So if you were to say infinite space, infinite power, or infinite energy within that space, then you're talking about an event horizon of the universe that continually grows, just like the number set would have to continually grow. But we know, as pseudo-intellectuals that we are, that all the numbers in the universe exist already. We just simply haven't spoken them to acknowledge that they exist. So it's conceivable, and I think that intellectually within our minds, because we can think of the fact and we know the fact, even a school child can conceive the numbers go up as far as they need to, and you put a minus on it, goes as far down as they need to go. And because you can split into fractions any number, that there's an infinitely divisible quantity as well. So it's infinity wherever you look within a number system. It's sort of the clue of how the universe might be put together. And that clue is best represented by a word with two letters. Is. And I think it's funny because is has an I in it. And I is always the imaginary number in mathematics for infinity. So the plural of I would be is. Isn't that kind of funny? Don't ask Bill Clinton what is. His definition of is sprayed all over a blue dress. But it's interesting. So I think this kind of gets you to that critical domain of thinking that really addresses the potential control that man has over what we perceive to be as time, to then travel through it. I don't think we know what we are. I think we can theorize what we are. What I think is kind of funny, and I'm going to just make fun of myself for a split second. In my brain, what we are is one of two things. Either we are the Kurzweil chemical bag in the brain cavity, and we simply turn into ashes, and we're sort of super insignificant at that point, relatively speaking to the universe. Or we have a symbiotic relationship with a life force, which is what I would call the soul, the spirit. Because I believe I've experienced things, as I mentioned in my God episode, that are unexplainable, yet very attainable, and other people have witnessed them as well in some cases, I think that I'm leaning towards the latter of those two theories. You know, the Fibonacci pattern, the golden rule, the golden mean of creationism, when we can look at just an artichoke and we can look at a flower, we see the electrical reality of some sort of spiraling mathematics, you know? And I'll throw this at you. Think about the, life force not being the slightest bit tangible to anything that we can measure, because I think we would have measured it a long time ago. However, it does disrupt and guide energy in its growth pattern. How something can interact with something and not be trackable is beyond me, right? If I can access a memory from, let's say, a soul energy that might be, we think we do have parts in the brain. Okay, I think studies have pretty much conclusively proven that our brain does participate in the matrix of memory, right? They're coming up with all these Alzheimer drugs that are trying to help people register their short-term memory into long-term storage, and that's really what the problem is. That's why an Alzheimer's person can talk about being 20. When they're 90, they can remember having a cocktail at some place with Theodore Roosevelt, but they can't remember what you said 5 minutes ago. If they've met you in the past, they know who you are when you walk in the room on a good day. If they've just met you as an orderly in some hospice, they may not remember you 5 minutes later because it's never been tracked into long-term memory, right? My grandmother, who suffered from dementia, which is sort of just a subspecies of Alzheimer's. I was in California, and she had her and I were talking on the phone constantly, and at no point could I understand that she had any type of mental issues. And then she, I guess, laid down on her floor at her house for 2 days straight and nearly died until my aunt found her by looking through the window. And they got her all rehabilitated, and she was much better and lived a couple more years after that. But when I went to visit her at her convalescent home, I turned the corner, and they said, she's going to have bad days and good days. Her major panic was not knowing where she was because, again, short-term memory of being put in a wheelchair and pushed into a room, even if it was a familiar room, it was like waking up, like me just teleporting to another room. I just didn't know, where the hell am I? It's not that I'm freaked out that there's a desk and a chair in the room. It's just, how'd I get here? So that was her major state of panic. But when I walked around the corner after not seeing her for a year, the first words out of her mouth was, "Mark," and she was happy to see me because I was in her long-term memory, But there's an anatomy of a computer, which is very, very interesting, that I think correlates with the way that the human body is designed, potentially. And it's very simple. We have hard drives that store long-term data, and we have memory, which is what's being processed at that exact moment. So anyone who's ever pulled up an old letter or an old book that you were writing, it was stored in a file, totally forgotten until you needed it, and you load it into your word processor and you start typing. And even as you're reading it, the metaphor of what's going on is happening right before your very eyes. You will not have remembered every word that you wrote until you read it again. You're like, oh, that's pretty good. Oh, that's really bad. But you're pulling it out of storage in your computer, putting it into its short-term memory, and then you're taking it out of your long-term memory as an iconic frequency of stimulating that data that's in your long-term memory. It's wild, right? We have to think about these things if we want to conceive of what we are, to figure out where we want to be in time. Anyway, I know you feel me. I'm just rambling on here. One reason why I like doing these deep thoughts that are sort of out there, and is that it may jog something in one of you. And just for one of you seeing this, you might just go, man, it's obviously not anything he just said. It's this thing. And you might be the first human being on planet Earth or within our timetable of, our post-Ice Age group of people that will have rediscovered something or discovered something for the first time that might give us a better perception of reality. Maybe you could figure out how to what time really is and figure out how to push through it. Maybe you'll figure out the symbiotic relationship, which is our consciousness. At a minimum, we know we have two constructs made of energy. Slow energy, which is this physical mass that is my mortal coil, and the fast-moving energy that is electricity that goes throughout my nervous system and makes this whole thing possible. That's still the same stuff, but it's definitely in two different states. But time, well, it's just a measurement of change. That's all it is. Again, I would encourage you to believe that the universe has no clock. It doesn't care. It's benign to the concepts of time. It simply changes, and you can measure it within a particular cycle to convince yourself that second one it's one way and second two it's the other way. Some other person might measure it in a completely different way. But whatever gets us there, that's where you should be. I'm going to be taking these deep thoughts and cleansing them down to sort of non-topical. I don't mean non-topical, non-current events. So the previous ones, I've started to kind of retire them. If I touched on anything that's sort of current affairs, I'm going to be pulling those out of circulation. So if you see numbers missing as you go back, that's why. Unfortunately, you have to get to the end of this episode to know any of that's the case. Everyone else will be confused. But if you get to the end of this and someone's going, hey man, I went back and this one's missing and that one's missing, you'll be the deep thought listener who knows the rest of the story. Now, usually what we say is go to mkultraradio.com. You can if you want. We have, our main show, which is a very topical show, it's going to remain a very current events program. From time to time, we'll touch on theories like these, like Flat Earth is coming in episode 100, because we need to lighten things up just a little bit. A lot of stuff's happened since the last time Kyle and I recorded just a week ago. I'm not going to get into that because I'll make this more current affairs, but just understand that the website is mainly to get to either these deep thought episodes, get you to the YouTube channel. If you haven't watched any of these, it just depends. If you want to see someone move their mouth and smoke cigars, that's the thing. But overall, we don't get a lot of viewership. That's cool because the people who do watch really do participate, and it's really cool. So again, I'm going to try to come up with some more really esoteric ones like time travel. It's just cool. It's, if we're all thinking about it, but we don't talk about it that often, that's where I want to create a deep thoughts. I've tried to go into other subjects. Some are so deep, it's really, really hard to wrap my mind around it. For me, it has to apply to society, whereby I want people to be more creative. I want people to be more happy. I want people to have more control over their own lives. I want them to be happier through skills and that kind of thing. So that's sort of where I like to put this. But every once in a while, I think it's good just to kind of expand the mind in these really esoteric subjects like time travel. So I know you get it. All right. Well, as always, thanks for listening. If you made it this far, again, at some point I'll come up with some trophy I'll give you guys for making it this far. As always, just take care of yourself and somebody else, and I'll see you in the next video. Over now.